Let's look at some more examples of how the net change theorem can be used. Although the net change theorem is often used to find the change in an object's position given the object's velocity function, this theorem can also be used for many other things. Suppose a rocket ship is traveling in such a way that it is utilizing fuel at a rate of 976 minus t raised to the 2.3 power gallons per hour, where t represents the hours since the rocket ship launched. Since we have a function for the rate at which fuel is being used and we know the interval goes from 0 to 5, we can apply the net change theorem and calculate this amount as the definite integral from 0 to 5 of 976 minus t raised to the 2.3 power dt. To proceed, we need to find an antiderivative of 976 minus t raised to the 2.3 power, and we get an antiderivative of 976t minus 1 over 3.3 times t raised to the 3.3 power. Now we need to find big F of 5 minus big F of 0. Big F of 5 minus big F of 0 is equal to 976 times 5 minus 1 over 3.3 times 5 raised to the 3.3 power minus 976 times 0 minus 1 over 3.3 times 0 raised to the 3.3 power. If we use a computer or calculator to get an approximation of this number, we get that the value of this definite integral is approximately 4818.6. It's important that we be able to translate this into plain English that someone who doesn't know calculus could understand. All that person is likely to want to know is that the rocket used approximately 4,818 gallons over the first 5 hours of flight. In an application like this one, they would not care whether you got the answer using the fundamental theorem of calculus or simply by typing the right definite integral into a computer-based tool. The net change theorem is important, so not only do we get a final numerical answer, but we know what that answer means, whether we got it by hand or by using a computer.